this lesson is going to be 1.8, and we're covering midpoint and distance formula. So when we talk about midpoint and distance formula, we have formulas. And some people get really scared of that because they don't like formulas and they look really long and confusing and hard to memorize. So I'm going to try to help you understand that there's really a way to do it without memorizing it, and that is if you just understand the actual problem. And so the midpoint formula, this is what it is. You should write it down. These little numbers at the bottom, like I'm going to show you which ones I'm talking about. That little 2 and that little 1 and that little 2 and that little 1, those are subscripts, and they're just descriptors. They're not actual numbers that you can add together or multiply or anything else. They're just descriptions. It's just like saying the second x and the first x, and the second y and the first y. So that's what those numbers are all about. Then I want you to understand all we're really doing is averaging these together. Because think about it, what's the middle? Isn't the middle like the average, kind of, right? So to do that, we just average the x's and we average the y's. And that's how you find the middle of 2 points, as you take the average. The other formula we need today is the distance formula. And again, you should write this down. And again, I will tell you that these little numbers down here are called subscripts. And so when I read it, I say x sub 2 minus x sub 1. Now, the number on the top, that is an exponent, and you will do math with that. I mean, I think you've seen that before, but I just want to remind you, those are actual exponents, whereas the ones in the bottom are not. They're not mathematical. They're just telling you a description. So we use the midpoint formula to find the middle of 2 points. We use the distance formula to find out how long something is, or the distance between 2 points. So let's take a look at this example. The endpoints of dt are 1, 2, and 7, 8. We need to take a second to graph those, so do that. Okay, just a reminder on how to graph points. If this dt is 1, 2, that means we go over 1 and up 2, and that's our point. And then t is 7, 8, so we go, and remember that that first number, this is actually going to help us out, so let's just go ahead and mark this now. This is my x number, and I'm going to call it x sub 1. This is my y number. I'm going to call it y sub 1. Those little ones just say that's the first point. And then this is my x sub 2 and my y sub 2. And the x, y's, you go x first and then y. This is your x-axis. This is your y-axis. So we're going to go x, y. So 1, 2 is here. And 7, 8 is here. So those are the points. We need to graph those points. The next question says, use the midpoint formula to find the coordinates of midpoint O. I don't know exactly where it is. It's somewhere in here. It's point O. It's somewhere in here. I don't know where it is. I need to calculate it. The way I'm going to calculate it, I'm going to show you 2 ways. I'm going to show you how to calculate it, and I'm going to show you just how to figure it out. Let's start with the calculation because that's kind of the harder part. So I'm going to use this formula that I have written down. What points do I put in there? Well, I labeled them a second ago. So I'm going to take my x's and put those together. So I have a 1 and a 7. I typically start with the 2 and go to the 1. So I'm going to say 7 plus 1 is going to go in my numerator, divide by 2. Why am I dividing by 2? Because I want to average them. I want to find the middle. The middle is the average. And then I'm going to take my y's, 8 plus 2, and I'm going to divide by 2. So I took this formula and I put my numbers into it right here. Now I need to work on this and simplify a little bit. So I'm going to come over here. 7 plus 1, that's 8, and 8 plus 2, that's 10. And they're both divided by 2 because it's the average. So I can go one more time and I can say 8 divided by 2, well that's 4, and 10 divided by 2, that's 5. And so I say this is my midpoint, and we were calling that midpoint O. Let's look at the graph, because another thing to do is to look and see if it even makes sense. So let's go over to the graph, and let's graph the point 4, 5, and it is right there, and that does make sense. First of all, it's right in my highlighted area that I was expecting it to be in. Secondly, it's right there on the dot, and if I look at it, it sure looks even to me. Okay, how do I know that that's even? Let's get back to kind of figuring it out instead of doing the calculation. All right, the calculation is important. It really is. But let me tell you about just how to think about it kind of logically. if we think about to go from D to T, I have to go all the way over here, and then I have to go all the way up here. Well, how far did I go? Well, going this way, I went 1, 2, 3, 4, 5, 6 boxes this way, and I went 1, 2, 3, 4, 5, 6 boxes this way. Well, what's half of 6? It's 3. So if I go 1, 2, 3, I should go here, and half of 6 this way, 1, 2, 3, should be here. And so I just went halfway, and I got to the middle by going halfway this and halfway of that. It's the midpoint, it's the middle. And so if you do that, you will get the right answer. Now, the formula, yes, it's important, but I want to show you just how it works also, because that I think will help you in the long run. Let's look at the next problem. The next one says to find GH. Remember, when it doesn't have a bar or anything over it, that means we're supposed to find the length. So let's take a second to graph these points, connect our points, and then we're going to find out how long is the line. Okay, so once again I've graphed it. So here's my segment. I'm supposed to find the length. I'm going to rewrite my formula here because it's way up there where you can't see it. So here's my distance formula. It looks kind of long and confusing. It's not. I'm going to first start off by labeling, and I'll just go up here and do it. This is my x1 and my y1. This is my x2 and my y2. Okay, I need to plug those in. So x2 is 1. x1 is negative 2. I need to put all that in parentheses and square it. Then my y's. My y2 is negative 2. My y1 is negative 6. And I need to square that. And I need to put a square root sign over the whole thing. Sometimes we start this out with a d equals, meaning the distance. It's a distance formula. So the distance equals this. Okay, now a couple things. If you have a TI-30XS, you can probably just plug this whole thing in and do it in one shot, and that's fine. I'm going to work it out a couple of steps at a time. So I'm going to go inside the parentheses and figure that out. 1 minus negative 2, 1 minus negative 2 is 3, and negative 2 minus negative 6, that's like negative 2 plus 6, that's a positive 4. So I just simplified those. I still need to square them. So I'm going to square them and come up with 9 plus 16, which is 25. And if I go to my calculator and I take the square root of 25, I get 5. So the length of GH is equal to 5. That is the length. Now, I want to tell you about another way. It's the same exact way. It's just another way of looking at it, and that is looking at it as a Pythagorean theorem, because for some of us that might be an easier way. And the reason I say easier is just I myself, I don't like memorizing formulas. And so the fewer formulas I have to memorize is better for me. Because I already know the Pythagorean theorem. That's a formula, that's true. But do you remember the Pythagorean theorem? It's just a squared plus b squared equals c squared. And so if I look at this, I can make this segment into a triangle. Well, how tall is this triangle? That's 1, 2, 3, 4 boxes. And it is 1, 2, 3 boxes down here. And so I can do Pythagorean theorem. I can say 3 squared plus 4 squared is equal to c squared. Well, 3 squared is 9, 4 squared is 16, and that is going to give me c squared. So that gives me a 25, because 9 plus 16 is 25. Now the last thing in the Pythagorean theorem is now to take the square root of both sides. So we're going to take the square root of both sides, and I get c equals 5. That is the exact same thing I came up with over here. In fact, if you look at some of the lines, they're the exact, look, a square root 25, square root 25. 9 plus 16, 9 plus 16. 3 squared plus 4 squared, 3 plus... The only part that's missing is this totally confusing part. So let's skip the confusing part, and let's just count and say this is 3 boxes, this is 4 boxes. Pythagorean theorem. I'm going to say you can do it either way. If this distance formula works best for you, great. If Pythagorean theorem works better, use it. The thing about the Pythagorean theorem is you kind of need the graph paper. And if you don't have graph paper, you're probably going to have to go back to this. So you might have to go ahead and memorize this anyway. But you know what? You can always draw a graph, can't you? Okay, so that's where that's coming from. And one more thing, the reason that we're subtracting is, let me go back and mark some things. So the bottom here, where it's a length of 3, I got that 3 because negative 2 minus 1, well, let me go the other way. 1 minus negative 2 is 3, which is what we did here. And then on our y's, we were here at negative 2, and we're down here at negative 6. And the distance between a negative 2 and a negative 6 is 4, which is what we did over here. So it's all the same exact stuff. Okay, so here they are. Now it's like I said, they don't give us a graph. But you know what? We can always draw a graph if we want to. So I'm going to go ahead and draw that graph to kind of get us started off. So like I said, even though they don't have a graph for us, we can draw one and that'll make our lives easier. So I have point E at 1, 4 and F at 5, 1. I'm going to plot those points. Okay, I got some things set up here. First of all, I plotted my points. The point 1, 4 and the point 5, 1 are here. I need to find the length of that segment. I also labeled my points over here, x1, y1, x2, y2. I think that step is really going to help you if you put that in there. I rewrote my distance formula so that I have it, and now I need to put those numbers in there. So my x2 minus my x1 is 5 minus 1. I square that, and then I add y2 minus y1, which is 1 minus 4. So I get 5 minus 1 is 4, and I square that, and I get 1 minus 4 is negative 3, and I square that. Now I need to get my calculator. And one thing is I put my negative in parentheses. That's always a good idea so that you just, you don't lose that negative sign, or you don't keep it if you're not supposed to. Because when I square this, this means negative 3 times negative 3, and negative 3 times negative 3 is a positive 9. So I get EF is 16 plus 9, which actually is what we just had a second ago. That's the square root of 25. So the answer is EF is 5 units long. That's doing it by the distance formula. Let me show you real quickly how to do the Pythagorean theorem. If you counted here, 1, 2, 3, 4, this side is 4 units long. 1, 2, 3, this side is 3 units long. I could do the Pythagorean theorem. So my Pythagorean theorem, on the Pythagorean theorem, the A and the B, you can change them up. That doesn't matter. It's always the C is the hypotenuse. That's the one that's across from the right angle. So C is the hypotenuse here. 3 and 4 can go in either spot. But if I take 3 squared plus 4 squared, that's 9 plus 16. I add those together, I get 25. And take the square root of both sides, and I get 5 equals C. So alternative method over here. Let's go and do the other one, GH. So we need to plot these points. Okay, so I've plotted my points. Here's G at negative 3, 1. Here's H at 1, 6. I need to use my distance formula, so I need to write that out. Okay, so I wrote out my distance formula. I'm going to come up here and get my numbers. So x sub 2 is 1, x sub 1 is negative 3. So I have 1 minus negative 3 for my x's, 6 minus 1 for my y's. So 1 minus negative 3 is 4, 6 minus 1 is 5. I need to square those. So 4 squared is 16, 5 squared is 25. I add those together. I need my calculator. I add those together, I get 41. On my calculator, I need to get a square root of 41. It's going to be a decimal. So I made wavy lines, which means approximately equal to, and I'm going to say approximately equal to 6.4. Okay, now where were we even going with this? Well, let's go back and look at the question. It says the endpoints of 2 segments are given. Find each segment length. Tell whether the segments are congruent. So this one was 5, this one is 6.4. No, they are not congruent. Let's talk real briefly about Pythagorean theorem. If we go from here over to here, that's 1, 2, 3, 4 points. We go from here to here, that's 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. That was hard to see. So my Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to take 4 squared plus 5 squared and see what that equals. So when I add those together, I get 41. Of course, I need to take the square root at the end. So now I'm going to take that square root and I'm going to get c, and I have to put this in my calculator, which I did over here, and I got 6.4. I just want to show you that Pythagorean theorem so you understand what's happening in the distance formula. Okay, we're done. And again, not congruent. That is the end of this video for lesson 1.8.